Here we have the integral of x cosine x dx, so I have the product of these two functions. I am going to be doing integration by parts, and we know that the formula was if we had the integral of u dv, that equals uv minus the integral of v du. So I need to identify what I'm calling u and what I'm calling dv. Couple rules of thumb. If you have one of the functions that would go to 0 if you differentiate it enough times, in this case x, first derivative is 1, second derivative is 0, that's generally a good thing to try for u. We see that the cosine x would just cycle between positives or negatives, sines or cosines. It wouldn't go to 0. So I'm going to call this one u and this one dv. So we have u equals x and dv equals cosine x dx. That means du is going to be dx and v must have been sine x. I can go ahead and apply the integration by parts formula then, and this will equal uv, so that's going to be x sine x minus the integral of v, that's sine x, du, that's dx. So that's going to be x sine x, and here we have negative sine x, so that's just going to be plus cosine x and then plus our constant of integration. Now remember, on any of these you could always check them by differentiating and making sure you get the original function back. So let's just quickly do that. So here's a product. First function times the derivative of the second function, that's going to be cosine x, plus the second function sine x times the derivative of the first function, that's 1. Over here the derivative of cosine x is negative sine x, and of course the derivative of a constant 0. Those would cancel, and you can see that it does in fact check.